We're now going to have a look at an outcome that's a categorical variable. And in particular, we're looking at the human resources data set still. And our outcome variable is going to be volturn, which stands for voluntary turnover, whether or not you choose to quit your job. And we're going to see how that is associated with sex, male and female. So having a look at this new variable, voluntary turnover, we're interested in the proportion of men that quit and the proportion of women that quit, and comparing those two. So we're going to be doing a 2-sample test comparing proportions. Now, just to get started, I'm going to treat voluntary turnover as a nominal variable, so I can have a look at it, and I'll look at gender again. So let's have a look at those two variables, and once again, we can see we've got about 3,000 men, 2,500 women in this data set. And in terms of quitting, well, looking at the probabilities under voluntary turnover, we've got about just a little over 10% quit rate. And what we're interested in seeing is how that separates out over the males and the females. So our goal here is to test a hypothesis of whether or not the quit rates are the same for men and women as they versus being different for men and women. We're not specifying which way they're different, so we're going to do a two-sided alternative. And because our outcome variable is a two-level categorical here, we're going to be looking at the proportions of quitters in males versus females. Don't forget, once again, that we are operating under the assumption that we have random samples from underlying populations. Formally, we are testing the population proportion equality against inequality. So the way that we are going to actually do that is, well, we'll first of all have a look at the fit y by x, where we associate gender and voluntary turnover, and that will give us the mosaic plot and the contingency table. And we can see the blues are the quitters. So looking at the mosaic plot, we're getting more quitters amongst the women than the men. How much exactly? We go down to the contingency table, and you can see here that amongst the females, that row-wise percentage is 12%. So we've got about 12% quitters amongst the females and only 10% amongst the males. So from a purely numeric point of view, we've got more women quitting, but the question is the difference observed here between the 10 and the 12 statistically significant? The only way to answer that is to go ahead and do a hypothesis test. So the way that I'm doing the hypothesis test in JUMP is to turn voluntary turnover back into a continuous variable, so it's now treated as zeros and ones. And when we go through the fit y by x dialog again, gender against voluntary turnover, well, we get a plot that isn't particularly useful because there are only two outcome values that voluntary turnover can take, 0 and 1. So this isn't particularly useful, but we can look for the means of this 0,1 variable. And when we do that, we find under the mean here 0.12 for females and 0.1 for males. In other words, we're looking at the proportions. So the proportion of female quitters and male quitters. And in order to do a hypothesis test on the equality of the underlying population proportions, it's right-click on the title bar and then t-test. Now we have the familiar output from the 2-sample t-test. Here it is down at the bottom of the output. A number of things I can look at. First of all, I can review the difference in proportions, negative 0.023 roughly. That's simply the 0.1 minus the 0.12. So a 2% difference between the two sample proportions. There's a standard error of the difference, 0.00849, and then the 95% confidence interval, negative 0.039 to negative 0.006. And the thing to note is that 0 does not lie in that interval. So 0 is not a feasible value for the difference. If your difference is not 0, then it's something, and therefore we don't have any evidence supporting the null hypothesis. We can reject the null hypothesis of equality of proportions and conclude that there is a difference. And just reviewing the data, we can see that women are more likely to quit than men. We could also look at the t-ratio, which here is negative 2.681, telling you that you've observed an event that's about 2.5 standard errors away from where you would expect it to be under the null. 2.5 standard errors is a lot by our usual cutoff of plus or minus 2, and therefore evidence against the null hypothesis. And finally, we can go down and have a look at this prob greater than mod t. That's a two-sided p-value, and it's only 0.0074, which is less than our traditional cutoff of 0.05. So a low p-value gives us evidence against the null, and this is a pretty small p-value, less than 0.01, so we have strong evidence against the null. Just reviewing the graph within the t-test output, the idea here is that you're looking at the distribution of the test, of the difference in sample proportions, the negative 0.002. That's the difference in sample proportions. This is the distribution of that quantity under the null hypothesis, and it's centered around 0 because that is the null. Difference in proportions is 0. The little red tick at the side here is the observed value of the difference in proportions, negative 0.0227. That's exactly at negative 0.0027. And then you can't see it very well, but there's a couple of shaded areas. They're shaded just a little bit here in terms of the dark blue color, but the two tail areas corresponding to that red tick mark are exactly the numbers that make up the p-value, 0.0074. Because the p-value is so small, you can't really see it very well, but that's the idea of the graph. It's giving you a visualization of both the observed difference in proportions and how extreme that is as compared to the null hypothesis. So that's our approach to testing two proportions through the two-sample t-test dialog, and you should only really be doing this if you've confirmed that the underlying assumptions when you're testing proportions hold true. And the way that we are working with the assumptions is that we want to make sure that for both the males and females, we have observed at least 10 positives and 10 negatives, 10 people who quit and at least 10 who didn't quit. So that's our standard sample size requirement on leading us to believe that the central limit theorem has kicked in and that this approach to doing testing the two proportions is legitimate.